Alrighty, this is a big one actually. 13D, looking at expected value, or the mean, also looking at variance, and also standard deviation. So in the past, you would have been asked to calculate the mean of things, obviously where you have some data. And obviously that in that particular case, that was some sample data that you were asked to calculate the mean. It's also possible, like we're going to do now, is to use the probability distribution to calculate the theoretical true value of the mean, and the variance, and also the standard deviation. And so what they're saying here is that when these are calculated from the probability distribution, they are known as the population parameters. So let's first of all have a look at the expected value, which is also known as the mean. Um, so here is an example. Yep. It says here a person may buy a lucky ticket for $1. Cool, a lucky ticket. It says here they have a 20% chance of winning $2. They've got a 5% chance of winning $11, and or otherwise they're going to lose. Yep. And the question is, you need to work out whether it's actually a good game to play. Now, in probability, when they're talking about whether it's a good game to play, the better games to play are the ones where you would win in the long run, rather than lose. So let's see whether it is a good game. So it says here, what we're going to do is let P be the amount of profit the person can take from each game. So again, if it costs $1 to play, in that particular case, the player can lose $1. Yep, if they lose, because it costs $1. But if you don't win, you lose that $1. If they win, then you could win that $1 on top of the $1 that you got, or that you put in, so it's $2 obviously. And then if you win again, you could win the $10 plus that $1 that you also put in. Yep. So the table that is created is listed here. Obviously, 20% chance of winning the $2. The $1 and the $1 that you win is here. The $11 is the $10 plus the $1 you put in is 5%. Obviously, if those two are 25% losing, you've got a 75% chance. So that's how they came up with that. So they're saying here, if you played that game 1,000 times, it says here you would expect to lose $1 about 750 times. Yep, because we're multiplying obviously that by 1,000. Again, if you're going to win $1, you'd win that about 200 times out of the 1,000, and you'd win the $10 about 50 times out of the 1,000. Now, way in which you can work out the expected chance, or sorry, the expected amount in the long run here, is we're going to multiply. What you're doing is you're multiplying each of these by those probabilities. So here, what we do is we multiply -1 by the 750. We're multiplying the 1 by 200 times, and we're multiplying the 10 by the 50 times. We then add those together, and we're going to divide it by the amount of games that we had here, which was 1,000, and it comes out to being negative 0.05 per game. So that's 5 cents is what you would expect to lose per game. Now, in this particular topic, the way we'd write the expected value, or expected value of the P, is negative 0.05. Yep. So again, there is a formula for calculating this expected value. And it says here the expected value of a discrete random variable x is determined by summing the products of each of the values of x and the probability that x will take in that value. So what you're doing is you're multiplying each of these together and then summing them together, and that's how it's written here. So it's the expected value of discrete value is determined by summing, the expected value is determined by summing the products of each of the values of x with the probability. So you multiply those together, and then you're summing them all together, so adding them all up. Now, another thing that you need to know is there's quite a fair few different ways in which they can ask you this and notate it. So here you might see the expected value of x written as such. We also know that the expected value of x can be represented by mu, which is this Greek letter here, mu. Also know that whether they write down the expected value of x or they write down mu, in probability we're also looking at it's the mean of x. So all these things, if they say calculate the mean of x or expected value of x or mu, it's all the mean, all doing this particular thing here. Alrighty, let's have a look at worked example 16. It says here a coin is biased in favour of heads such that the probability of obtaining a head on any single toss is 0.6. It says the coin is tossed 3 times and the results were noted. It says if x is the number of heads obtained on 3 tosses, find expected value of x. So cool, it says here the following probability distribution can be found by listing the outcomes in the sample space and determining the values of x and the associated probability for each outcome. So they've worked this out and they've listed it in the table here. So to go ahead and find the expected value of x or mu or the mean, it's all the same thing. What we need to do is use the formula from before, where we multiply each of these and we add them together, so sum them together. So you can see here they're doing 0 multiplied by this, plus 1 times this, plus 2 times this, plus 3 times this, adding them together. In this particular case we get the expected value or the mean as being 1.8. And so really what this means is if the experiment was repeated many times, then on average you would get 1.8. You would get 1.8 heads per 3 tosses would be observed. It says sometimes we wish to find the expected value of the function of x. This is determined by calculating the values of the function for each value of x and then summing the products of these associated probabilities. Cool. Again, you might have a function. Yep. So it says the expected value of g of x is given by the following. Expected value of g of x. Again, you're going to be multiplying g of x by p of x and then adding all of those things together. Okay. So it says here for the random variable x, which was defined up in example number 16 that we just spoke about, it wants us to find each of these. So again, expected value of 3x plus 1. So again, you're using this here, 3 times 0 plus 1 is obviously 1. 1 times that, you list it down. 3 times, I'll fit this in here, 3 times 1 is 1, oh sorry, is 3, plus 1 is 4, 4 times that, and so forth and so forth. Then we multiply each of those together and add them together, and we get 6.4. Likewise, you can do the same sort of thing here, except we're squaring those x values. So obviously in the table you got x squared multiplied by its probability, 1 squared, and so forth. Multiply those together, add them together, we get 3.96. Okay. Now there's a little bit of information here that goes on and shows that there are a few little rules that can be followed, and it says in this particular case here, if you've got the expected value of 3x plus 1, we saw it was equal to 6.4 in our books, and they're also saying if you've got 3 times the expected value of x plus 1, so basically it's pulling that linear linear value out the front, it still comes out as being 6.4. It's the same. Yep. And so that's where this expected value comes to play here, this particular rule, that constant value, can be pulled out the front and you will still get the same value. However, what they're trying to say here is, please note that if you're expected to find the value of the expected value of x squared, it's actually different than the expected value of x and then squaring that. They are not equal to each other. So that'll pop up a little bit later on as well. Cool, so just keep a note of that. Worked example 18, we're powering through them. It says here, for a $5 monthly fee, a TV repair company guarantees customers a complete service. It says the company estimates the probability that a customer will require one service call in a month as 0.05, probability of 2 calls is 0.01, and the probability of 3 or more calls at 0. Each call costs the repair company $40. It says, what is the TV repair company's expected monthly gain from such a contract? Alright, so what we're listing here is obviously if they've got 0 calls, they're going to make that $5 that it costs them, no problem. If there's 1 call out, yep, I guess again it's going to cost the company $40, but they got the $5 from the customer anyway, so they're at a loss of $35. If there's 2 call outs, obviously it's just the same as that, but then another $40 off the previous one, so it's negative 75. Yeah. And so from here they've also listed those probabilities. So they said it was 0.05 if it's 1, and there was 0.1 if there was 2. They've said no one calls out more than 3, so that's 0. Obviously, the total of this has to add up to 100%, so therefore this has to be 0.94. So that's how that came about. So again, if you were asked to find the TV repairs company's expected monthly gain from such a contract, again, what they're doing is the expected gain is, again, you're summing the product of each of these together. So multiplying these together. Now what they're saying here is we're only going to add them together and sum them up to and including the 2 here, because there's no point, there's nothing else up past 2. So again, 0 times 5, oh sorry, my apologies. So we're only summing up into these values to work out that expected value. 5 times 0.94 plus negative 35 times 0.05 plus negative 75 times 0.01. Summing those together, we get 2.2, which is about $2. Well, which is $2.20 per month. They're expecting to gain from each contract sold. So overall, they're still making money per customer, which is cool for the TV company. There is the alternative solution, which the textbook talks about, which is basically using the other information that we spoke about over here. They're saying let x be the number of calls received, then the gain is 5, take away 40x. So in this particular case, expected gain is 5 times 40, 5 take away 40 times the expected value of x. So remember, this is like the linear thing that we spoke about, where that can be pulled out. Yep. And so in this particular case, if we're going to do that, we get 1 times 0.05 plus 2 times 0.01, which is 0.07, is the expected value of x. And we can then obviously run that calculation and still get the $2.20 as previously determined. Alright, so that's obviously the expected value of x, or mu, or the mean. The next thing that we need to talk about is variance and standard deviation. Really, some people may understand what variance and standard deviation is about, but essentially what we're saying here is the mean is the long run average value of a random variable, but it's saying here it's often useful to measure how close to this mean possible values of a random variable are, and really that is looking at the measure of spread. And so a good way to measure that variability, or the measure of spread, is to use variance and also the standard deviation. So what you need to know is there's some rules. Again, I would be definitely putting these in your notes. It says here the variance of a random variable x is a measure of the spread is a measure of the spread of the probability distribution about its mean or the expected value, which we know is mu. So to calculate the variance of x, it is the expected value of x take away mu, yeah, and squaring that value. Yep. Now, again, when you see other notation and things like that, one of the ways in which they write variance is to use this sigma which is, as we said, the lowercase um, value or letter in Greek. So that's sigma, but it's sigma squared is the variance. Yep. Leads us to the next thing, which is if you've got the variance, which is sigma squared, we can calculate very easily the standard deviation if you have the variance. It says here the standard deviation is just the square root of the variance. Yep. So really, if you take the square root of the variance, you end up just with this sigma, which is what it is denoted as. Sorry. So yeah, if you get the variance, square root it, and you get the standard deviation. So it's pretty straightforward. Alrighty, let's have a look here now at example number 19. It says here, suppose a discrete random variable x has the probability distribution shown in the table that's listed here. So we've got negative c, chance is 0.5, and to get a positive c, it is 0.5 as well. Alrighty, so first thing it says, first of all, it's ultimately asking us to find the standard deviation. So in order to work out the standard deviation, we need to move through a few things and work through it. So the first thing we want to find is mu, or the mean, the expected value of x. So we know how to calculate that. So writing out the rule, we multiply each of these and we sum them together. So you can see here they've multiplied them and added them together. In this particular case, it's 0. So the mean, or the expected value of x, is 0. Next, what we're going to do is we want to find the variance, which is sigma squared, or variance of x. Here is the rule for that. So again, it's the expected value of x take away the mean squared. Now, we've found out that the mean was 0. So each of these is going to be just the x value squared. Yep. When we're doing the calculation, because if that's 0, that just ends up being x squared. So expected value of x squared, like we were doing in previous calculations, you square this value and then you multiply by its probability. So negative c, and make sure you put it in brackets as well, negative c squared multiplied by 0.5 plus positive c squared multiplied by 0.5, add them together. Again, note here where you've got negative c squared, when you multiply that, or square itself, it becomes positive c squared. Yep. So ultimately, this plus this here is c squared. Yep. So we've got the variance is c squared. Don't just finish just yet. They're actually asking for the standard deviation, not the variance. So as we said before, to calculate the standard deviation, what you need to do is take the square root of the variance. So obviously if we take the square root here of the variance, square root of c squared is just going to become c. So they've written down the standard deviation is just sigma, or standard deviation x is just c. Cool, so hopefully that clears that up a bit. There's a fair bit going on there. There is another alternate way in which you can calculate variance, and again I would be making a note of this. This can be a lot easier sometimes as well, rather than working through each of those steps. So it says here the variance of x is equal to the expected value of x squared, take away the expected value of x, and then that squared. Now we spoke before, these things are not the same. Okay, so you have to run this calculation, which is different than getting the expected value of x and then squaring it. Okay, so just be careful not to go, oh, that's the same as that. Not at all. Yep. So let's have a look at what I'm talking about. It says here, find the probability distribution shown. It says find the expected value of x squared and then find the expected value of x and square that. And then by doing that, we'll be able to plug it into the formula and get the variance of x. So first, we need to find the expected value of x, which is basically finding the mean. We are multiplying each of these together and adding them together. Obviously 0 times 0.08 is just 0. They haven't even written it as part of the calculation here. But we're multiplying them. 1 times 0.18, 2 times this, 3 times this, add them together and we get 2. So E of x is 2, the expected value is 2. From here, if you are asked to find the expected value of x and squaring it, we already found that out just by here, that's the mean. We can square that value. 2 squared is obviously 4. We've found out what the expected value of x squared is. It's 4. On the other hand, when we want to find out what the expected value of x squared is, what we need to do is obviously square this value before we do that multiplying. So obviously here, 0 squared times that, it's just still 0. 1 squared is 1 times that. 2 squared is 4 times that. 3 squared is 3 times that. Sum them or add them together, we get 4.84. So now that we've got the expected value of x squared and the expected value of x squared, you can plug them into that formula. So we said before that the variance of x is equal to the expected value of x squared take away the expected value squared. That's just the writing a different notation again using mu. So running our calculation, it's this here 4.84, take away the 4, we get the variance as being 0.84. Another thing is you can work out the variance if it's linear like this by looking at that a value, and that comes out the front squared. They are equal to each other, and that can be useful in this example that's here. It says if x is a random variable such that you've got the variance of x is equal to 9, it says find the following: variance of 3x plus 2. So from this formula here, that 3 can live out the front and square it. Yep, it's the same. Doesn't matter what this b constant is here. Again, if you pull that out the front, you've got 3 squared multiplied by the variance of x. 3 squared is obviously 9. They've told you up here that the variance of x is 9. 9 times 9 is 81. We can work that out. Another one here, if you ask for the variance of negative x, again, you can use this here. Negative x is the same as negative 1 multiplied by x. Yep, so that's that a value that's just here. So again, that can be pulled out the front and be squared. Note, you need to put the brackets around that negative value just to make sure the calculations are correct. When you square it, negative 1 squared obviously becomes positive 1. So positive 1 times the variance of x. We know the variance of x was just 9 from up here, so the response here is 9. Cool. Where are we at? Oh, still more to go. Cool. It says here, interpretation of standard deviation. It says we can make the standard deviation more meaningful by giving it an interpretation that relates to probability distribution. So again, this will be explained in a little bit more detail later on down the track. Yeah, standard deviation can relate to probabilities nice and conveniently. So it says here, chocolate bars. Number of chocolate bars X sold by a manufacturer in any month has the following distribution. Cool, they've listed in the table. It's then saying what is the probability that X takes a value in the interval between, so this here, where you've got mu, or the mean, take away 2 standard deviations. So it's basically saying, so you've got the median value in the middle. Sorry, when I say the median value, I mean the mean value in the middle. This is 2 standard deviations below that mean. This here means 2 standard deviations above the mean. So saying what's in between, what's the probability that's going to be in between each of those. So here's how you go about calculating it. It says first we must find the values of mu, so the mean, and also the standard deviation. So to calculate the expected value of x, or the mean, again, what we need to do is we are multiplying each of these together, and then obviously summing that response. We get 225. Next, it says before determining the standard deviation, which is sigma, we need to find the variance, which is sigma squared. So like we saw before, here is the formula to calculate variance. So we need to run these calculations. So obviously doing this here, expected value squared, and then also we had the expected value of x here, and we can square that. We can square that there, which is the 225. We get the variance is 55,000, which is this part here. Take away the 225 squared. Variance is equal to 4,375. Cool, so we've got the variance. Remember, once you've got the variance, you can then go and get the standard deviation by taking the square root of that. So the square root of, obviously, 4,375 is 66.14. That is the standard deviation. Cool, so we've got these things now. Now the good news is what they were asking ultimately at the start was to see what the probabilities were that lie between those two intervals. So 2 standard deviations below the mean and 2 standard deviations above the mean. So if you have the median value, which we worked out up here, which is 225, and you take away 2 lots of the standard deviation, so 2 lots of 66.14, you end up at 92.72. Here, if you have the mean, which is 225, and you add on 2 standard deviations, so adding on 2 lots of this to 225, you end up with 357.28. So that's obviously what the calculation they're looking for. However, because it's based on this table here, we need to utilize the values that relate to that probability distribution table. So this here relates closely to that 100 at the start, and this one here is we're rounding it down to the 300. Yep. So really what they're now looking at based on these is the probabilities between 100 and 300, and again, if you add these together between 100 and 300, you'll find that it is 0.95 or 95%. Now, just as a side note, what you'll see here is it says in this example 95% of the distribution lies within 2 standard deviations either side of the mean. It says while this is not always true, in many circumstances it is approximately true. And so you'll find that for many random variables, the probability that x is in between the 2 standard deviations either side of that mean, it is approximately 0.95 or 95%. Alright, last example, it says here, a manufacturer knows that the mean number of faulty light bulbs in a batch of 10,000 is 12. So that's the mean. And there is a standard deviation of 3. It says he wishes to claim to his clients that 95% of the batches will contain between C1 and C2 faulty light bulbs. He wants to know what those values of C1 and C2 will be. So again, he's ultimately saying, again, the probability is going to lie between 2 standard deviations, because as we said before, 95% is 2 standard deviations either side of that mean. If he wishes to claim that, then here to the left of the mean, or the value below, it's going to be 2 standard deviations subtracted from that mean. So again, if his mean is 12, and he's got a standard deviation of 3, if he takes away 2 standard deviations from the mean, 2 standard deviations would be 6. 6 subtracted away from the 12 is obviously 6. So C1 has to be 6 in that particular case. And likewise, it has to be 2 standard deviations above is the other one. So 2 standard deviations obviously is 6. Added onto the mean is going to be 18, is how that calculation takes place. Whoa, there's a fair bit of information there. Again, these things that are listed in the section summary are imperative that you put into your notes. This will take some practice. You do need to know all of the terminology and also all of these rules. Thanks for listening. Bye for now.